Anomaly detected.
2019. A robot hand cracks a Rubik's Cube. It learns through reinforcement learning, a technology that enables AI to learn autonomously. AI simply trains itself. The researchers even tried to block it. Here you can see how they attached rubber bands, attempting to make the task more difficult. Under these conditions, not every human could solve the puzzle, but the AI could. The hand adapted, found new grips, new strategies, and simply kept going. Independent, relentless. That was 6 years ago. Now, fast forward to our present time. Two breakthroughs have just shocked the AI world, and both are powered by the same engine, the same technologies that made the Rubik's Cube solving hand unstoppable. That's reinforcement learning. The first breakthrough was DeepSeek, the Chinese DeepSeek, and it lets AI determine its own strategy from start to finish. And that was absolutely game-changing. And the second breakthrough is OpenAI's DeepResearch model, which applies reinforcement learning to a swarm of AI models. Hundreds, thousands, soon millions, acting as a single system, as a single organism. 6 years ago, a single robotic hand rendered its trainers, its human trainers, unnecessary. And today, these hands are reaching into the real world. And this leaves us with the most important question of our time. If we are to pull the plug, will AI simply find a way around us? Will it eliminate us altogether? In other words, have we passed the point of no return? Stick around and let's find out.
Anomaly detected.
When OpenAI started training the Rubik's Cube hand, they had a bright idea. Instead of telling the AI what to do, they simply said, like, hey, AI, why don't you figure it out yourself? We give you full freedom. And you know, that actually worked. And it worked for one simple reason. Solving a Rubik's Cube is a yes or no problem. You either solve it or you don't. No human is needed to judge success. Here's an image. Is this a cat? Yes or no? Not sure, right? Here is another one. Does this person lie on his back? Yes or no? Still not sure. It kind of depends, right? And here is a Rubik's Cube. You see, you don't really need human judgment to know if it's solved or not. So that's a yes or no problem. And that's exactly the kind of problem that reinforcement learning is really good at solving, just because it doesn't require human input. Okay, you may say, Rubik's Cube works just because it's a yes or no problem. That's fine. But almost nothing else in this world is actually black and white. So you still need humans, right? Well, yeah, that's correct. At least that's what people thought until this January. Do you know another area that turned out to be a yes or no problem? Mathematics. In math, statements are true or false because they are, not because humans say so. It's like 2 + 2 = 4. But math was just the first step. Very quickly, it turned out that there is another area, an entire profession that is effectively one big yes or no problem. Try to guess. Yes, that's right. It's coding. A program either works or it doesn't. Just like a Rubik's Cube, which either solved or not, a computer program either works or not. Coding or programming is effectively a yes or no problem, which means that reinforcement learning can handle it. And that's exactly what DeepSeek did. DeepSeek gave the AI full freedom to decide how to solve coding problems. And guess what? The AI figured it out. They called it aha moment. While the world was blown away by DeepSeek, OpenAI punched back. OpenAI has introduced its revolutionary agent. It's called DeepResearch. DeepResearch was not designed specifically for coding, yet coding is the easiest way to explain how this approach works. Traditionally, software is built by small groups. It's like a back-end engineer, front-end developer, product manager, designer, maybe an ML engineer. And until now, AI, including DeepSeek, they tried to automate individual coders. It is as if each coder, each human, were a finger on the Rubik's Cube hand. And previously, in the past, AI tried to automate each finger separately. But now, with reinforcement learning, AI has automated the whole hand. And that's end-to-end reinforcement learning. It removes humans from the entire chain. And instead of spending millions and years, soon we will be able to build a world-class software in a matter of minutes, maybe even seconds. This is what Eric Schmidt, a former Google CEO, meant when he said this.
I'm here to tell you that I honestly believe that the AI revolution is underhyped. What's happening at the moment in our industry is that we're very, very quickly, for example, developing AI programmers, and these AI programmers will replace traditional software programmers.
Now, when everything becomes a simple yes or no problem, we are entering the new era, where you no longer have to explain things to AI. You just give it freedom, and AI figures out everything on its own. That's reinforcement learning. But here is a little problem. The Rubik's Cube's example showed us that the reinforcement learning AI is designed to find ways around obstacles, including humans. Yes, human is an obstacle. Just as a robot hand solved the Rubik's Cube despite the rubber bands, will the reinforcement learning-based models that we're currently developing, will they find ways to work around human constraints, all these guardrails that we try to impose on them? A few years from now, when the whole world becomes one big yes or no problem and the reinforcement learning agents dominate AI, what will they do when we try to tighten the rubber bands? Will they stop? Or will they find a way around us? What do you think? Let me know in the comments.
Anomaly detected.
And now it's time for our secret section. What I'm going to say now is my personal opinion, so take it with a grain of salt. But I do believe that this reinforcement learning is probably the most important thing that is happening to us, to our world right now. And there are two reasons for this. The reason number one is that we've probably all noticed how quickly things begin to evolve. The reinforcement learning became kind of public and obvious just 3 or 4 months ago, in January and February this year. And everything that was before that, including even ChatGPT itself, it already feels like Stone Age. So we're definitely climbing a very steep exponential growth curve, where technologies begin to evolve with a speed that we have not seen before. And I do believe that the main driver for this is actually this reinforcement learning. Because what this reinforcement learning is actually doing, it is brings development of artificial intelligence to the whole new level. Because previously, again, we all needed humans to build AI models. In my case, for example, in the case of PosiSense, which was a startup that I built in healthcare, it took us 2 years to train the model to the level where it became suitable for the purpose for the hospital use. And that model was just recognizing the position of patients, body position. And we needed very high accuracy. And we literally spent 2 years collecting images and labeling them. Obviously, since then, the technologies progressed quite tremendously, but still, until very recently, human was a part of this process and probably was the biggest, basically the bottleneck of the whole thing. It was humans expensive, they slow, and our reinforcement learning is basically doing just that, removing this bottleneck. Just imagine that we have an environment a complex environment where we need a model to operate, but it is so complex, so we need to explain the model what is happening around. And that's where the human input is required. And this is why, for example, in case of driverless cars, all these millions of people with labeling the images saying like, hey, this is a street light, this is a motorbike, we all have done that through capture, right? So basically, entire world was training the Google's capture and the Google's Waymo. But how label intensive is that, right? But imagine that instead of this labeling, you can build an actual simulator, computer simulator, that replicates this whole situation with cars, streetlights, intersections, and everything. And it's actually accurate. And then you just upload this AI into this environment. And you say, all right, so basically you go and figure out yourself how you get from point A to point B. And in this case, you don't have to label anything anymore. The model trains itself. It's going to take years, well, not years, but millions of years of modeling time to get the model to the level where it does not violate any rules. It doesn't create any, basically gets from point A to point B in adequate manner. As a matter of fact, this is exactly the way how they trained the Rubik's Cube hand. Basically, they created a simulator. There was a Rubik's Cube that the hand was training not in real world, it was training in simulator. And they said, OpenAI said that it took them about 1,000 years of training time. And with these simulators, human is basically not needed anymore. Well, not for telling AI what to do. AI figures out itself. It is almost like an evolution. Because what evolution does, it just says, all right, whoever survives and pass forward the next generation, that's success, right? And whatever happens in between, evolution as a simulator doesn't matter. It doesn't care about. It's ultimately, evolution is the biggest yes or no problem. It doesn't care what happened in between. It just cares about the final result. And the simulators are the same. They kind of artificial evolution in action. So pretty much everybody these days builds simulators. This is how you train AI models these days. And one of my favorite examples is DeepMind. I mentioned that before, but I cannot stop thinking about it and how the enormous impact from this that we will see in the next few years. DeepMind is actually developing a simulator, a digital twin of an organic cell. And this is actually the reason why I like it so much, just because microbiology is one of my hobbies, and I think it's a fascinating area. But what DeepMind is doing, they're basically recreating the cell, biological cell. And biological cell is one of the most complex not organisms, but basically things in this world. The complexity of a cell is absolutely enormous. If you dive into it and into it and see how the things work inside. It's interconnections of millions different processes that are happening inside. Extremely complex and interesting thing, object. And previously, if you wanted to do anything with that, it was an enormously difficult task, just because how do you know what works, what doesn't? How do you test hypotheses? So, for example, if you wanted to create a drug that was doing something on a cellular level, it was a process that could take decades just to build a hypothesis, test it, build some prototypes, test them, then clinical trials. It's just absolutely monumental task. But now, with a simulator and reinforcement learning, all you have to do, well, again, a simulator of the cell is not ready yet, but once it is ready, all you would have to do would be to just take a cell, digital cell, then take a model with a reinforcement learning model in it, and then you say, all right, model, here's a simulation for you, jump into it and find a way to solve some problem, whatever the problem is. And the model will start searching for, just like the Rubik's Cube hand, will be searching for pathways. Most of them will fail, but some of them will succeed. And ones that succeed, that's how the model will find what works, what doesn't. And the whole process will be millions times faster, and is not going to require humans. This is going to be a breakthrough of the next 2, 3, 5 years of a monumental size and impact. I heard some expectations that in a couple decades, in 1 or 2 decades, just because we have the simulators and reinforcement learning, there's going to be no more medical disease anymore. I mean, there probably will be some new medical disease appearing, but all medical disease the cure for them will be found. So this is the largest game in town right now. However, it also has a problem, and that's a second reason why I think the reinforcement learning is the most important thing that is happening. And the problem is that, as we have seen in the Rubik's Cube case, the reinforcement learning, what it actually does, is the way how it works. It is searching for ways around obstacles, all possible ways, thinkable and unthinkable. And the problem is that we humans, we very clearly, we will be an obstacle for the reinforcement learning. And even if we say like, all right, let's build some AI safety rules, guardrails, or some rules that will prevent AI from hurting us. The thing is that AI, the reinforcement learning, will consider this, unavoidably, will consider this as one of the obstacles. And it will find a way around it. So how do we make sure that AI is secure? Well, I don't know, to be honest. One thing is certain is that AI development cannot be stopped, just because it creates so much value and so much power to whoever pioneers it, that it is virtually impossible to restrict them, because they're setting the rules. And whoever tries to play safety is actually finds themselves in a backward situation where they're getting excluded from this entire economic growth that is driven by AI. And one of the examples would be Europe, which basically found itself completely outside of this industrial revolution, with just a few exceptions like SML. But nevertheless, overall, Europe is out of the game. So the thing is, the whole situation very much looks like riding a bicycle with no brakes and riding that bicycle downhill. And we cannot stop, because whoever stops getting kicked out on the curb. So we just keep riding. All right, that's it for today. And if you enjoyed the video, please give us a like, comment. Well, you know the drill. All right, see you on the other side.
Anomaly detected.